Hello everyone, this is Shudhanshu Sarkar. I'm an Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. So today I'm going to talk topic on electrical circuit and networks. This subject is designed for the diploma second year student, third semester student. So diploma third semester module total syllabus is divided few units, so I have to cover the unit 2, 3 and 4. So in unit 2, the previous lecture was a study of J operator, and today I'm going to talk about this impedance and reactance. This is the basics of AC circuits. So my today's topic of discussion is impedance and reactance of AC circuit. So impedance and reactance is a very important topic, important factor or element. You have to realize, you have to understand, otherwise you cannot solve the circuit. So this is called the basics of the circuit analysis or circuit theory. So today's lecture, especially I will talk on this impedance and the reactance. Look very carefully. This chart, from this chart you can realize anything and everything about the resistance, reactance and impedance. Resistance, you know, from Ohm's law, you all are very much aware of this resistance, because I think all of you have some idea about the resistance. From Ohm's law, we can easily define that V equals to IR, and from there we can define that the resistance is equals to V divided by R. And you know the unit of the resistance is Ohm. Now the symbol of the resistor, you all know, this is the symbol of the resistor, and resistance is represented with capital R or sometime in small r. And for reactance, reactance is also V by I. Reactance is represented by X. So X equals to V by I. The unit is same like the resistance, it is ohms. The reactance is basically divided into two parts. One is inductor and one is capacitor. So XL is basically the symbol of the inductive reactance, and you know that XL is omega L. And capacitive reactance is XC, that is represented by 1 by omega C. So XL equals to omega L. When it is an inductor, the reactance is XL equals to omega L. What is L? You know that L, what is L? L is the inductance. And what is omega? Omega is 2 pi F. Now for capacitor, if someone asks you to find, tell me the reactance. So for capacitor, the reactance is called the capacitive reactance, where X equals to 1 by omega C. So C, here C is called the capacitance, and omega, you know that it is 2 pi F. So for resistance, R equals to V by I. For reactance, X equals to V by I. Reactance is two type. One is inductive reactance, one is capacitive reactance. This type of symbol is there, you have to write XL. If this type of symbol is there, you have to write XC. That is called the capacitive reactance. Now, what is impedance? Impedance is also V by I, and the unit of the impedance is also ohms. So what is impedance? Impedance, it may be the relation between the resistance and inductance, is the relation between the resistance and the capacitance when these are connected in series. It is also the relation between resistance, inductance, and capacitance. Now, follow the circuit. In this circuit, a voltage source is connected and a load is connected. So, through the circuit, the I current is flowing. And if the load is only resistance, the equation is V by I. You will find a symbol like this. But if inductor is connected here in the load, then you will find equation XL equals to omega L. If capacitor is connected in this particular part, you will find this symbol, and this is the capacitive reactance XC, that is equals to 1 by omega C. Now, if in this load part, if these both are connected, or in the circuit if both are connected, then what will happen? Both are connected means if resistor and inductor both are connected, then the impedance is equals to root over R square plus omega L whole square. That means R square plus XL square. And you know that XL equals to omega L, so omega L whole square. R square plus 1 by omega C whole square if resistance and capacitance is there. That means R square plus X square, because X equals to 1 by omega C, so 1 by omega C whole square if it is a series RC circuit. And for series RLC circuit, what will be the value of the impedance? That should be equals to R square plus omega L minus 1 by omega C. R square plus omega L minus 1 by omega C whole square. So this is the equation of impedances. And here, for all the circuit, I consider all the equation as a scalar form. So after 2-3 slides, I will talk about the vector form. That means in this slide, I define everything without J, the J operator, which topic we discussed in the previous lecture, that is lecture number 7. Now, so in this way, we can understand that what is resistance, what is reactance, and what is impedance, what is inductive reactance, what is capacitive reactance, what is omega, what is the meaning of series RL circuit, what is the meaning of series RC circuit, what is the meaning of series RLC circuit. And we can understand the equation of impedance when it is a series RC circuit, when it is a series RL circuit, and when it is a RLC series circuit. So in this way, we can define the resistance, reactance, and impedance. Now, in this slide, you can find a symbol of a inductor. So what is the name of this symbol? This is called the inductor. So, and what is omega L? Omega L is called the reactance. And omega L, omega, you know, this is the value of omega is 2 pi L. And what is L? L is the inductor. So why I draw this apple here? What is the name of this apple? What is the name of this fruit? This is apple. How can we measure this fruit? We can measure with the mass. We can say that the mass of this apple is 50 gram. Like that, the measure of the inductor is the reactance. So this is the name of the symbol is the inductor. So name of this fruit is the apple. The measure of this fruit, we can measure it with the weight, with its weight, that is 50 gram. So you can measure the inductor with reactance, or this value is also called sometimes impedance. I think it is clear now. The symbol, the name of this symbol is the inductor, and the measure, we can measure this inductor with the help of this reactance. When it is inductor, then the measure is omega L, and the name of this omega L is the reactance, the inductive reactance, because the inductor is here. I think it is clear to all of you now. Now go to the next slide. What is this? This is the capacitor. So like previous slide, what is the measure of the capacitor? Reactance or impedance. What is C? C is the capacitor. So what is the name of this reactance? This is called the capacitive reactance. So the name of this fruit is apple. The name of this symbol is capacitor. The measure of the symbol is 100 gram. And the measure of this capacitor is inductive reactance, or sometimes it is impedance, I think, and where omega is the value of 2 pi f. Next, in this slide, we are going to talk about the impedance. What is impedance? For that, we have to draw a circuit first. Here in this circuit, we have a resistance and a inductance. Both are connected in series. So the measure of these inductance is omega L. This is called the reactance or impedance, and the L is the inductance. Now if we consider the whole part, then what will happen? If we consider the whole part means this part R and L. So the name of this whole part consideration is called the impedance. So what is impedance? Z equals to root over R square plus this omega L whole square. So this is the impedance. You can find the value of the impedance with the help of R and L. And the equation is Z equals to root over R square plus omega L square. Now, move to this slide. This slide is slightly different from the first slide, from the previous slide. That slide was the first one, I think so. Okay. So what is the difference between these two slides? In the first slide, there was no J. I already told on that slide. That was a scalar, and here we are considering vector. So for resistance, V by I. For reactance, X equals to V by I. For impedance, Z equals to V by I. Unit of all these three is ohms. This is the symbol of the resistance, symbol of the inductor, capacitor. So if it is a vector, then XL equals to J omega L. Only J is coming. We are multiplying with J. For capacitor, 1 by J omega, that is equals to 1 by J omega C. If we multiply J in numerator and denominator, then minus J by omega C is minus. So Z, what will be value of Z? R plus J omega L. For series RLC circuit, R plus J omega L. For series RC circuit, R plus 1 by J omega C. R plus 1 by J omega C. And the impedance for series RLC circuit R plus JL plus 1 by j omega c, combination of these two, R plus j omega L plus 1 by j omega c. In this way, we can find the value of the inductive reactance, the capacitive reactance, and the impedance of series RL circuit, series RC circuit, and series RLC circuit. Now, let me talk about a series RL circuit. So, in a series RL circuit, we are considering voltage source V equals to Vm sin omega t, AC voltage source. So, total voltage here across this source is V. Now, we have inside the circuit, we have a resistance and a inductance, resistor and inductor. The voltage across the resistor is VR and the voltage across the inductor is VL. We are considering this. Now, here the resistance is R and the inductance is L. The inductive reactance is omega L, where omega equals to 2 pi F. So, what will be the value of this impedance? That will be equals to Z equals to R square plus omega L whole square. So in this way, we can find this. Now, if some situation occur where R is not there, that means the value of R will be equals to 0. So only inductor is there. Then what will happen? Inductive reactance will be omega L, where omega equals to 2 pi F. So impedance value will be R square plus omega L whole square, but R is 0. So only Z equals to root over omega L whole square. That means this root and this square will vanish. So only omega L will be there. So for a, if inside the circuit, if only a inductor is there, no resistor, so impedance will be equals to omega L. For that case, the condition is resistance should be equals to 0. Now, look, this circuit, here, the first circuit, both was there, second circuit, resistance was not there, resistance 0, third circuit, inductor is not present, only the resistance is present, then resistance R, inductance L equals to 0, inductive reactance will be omega L, that is 0, where omega equals to 2 pi F. So what will be the impedance of this circuit? The impedance Z equals to R square plus omega L whole square, but omega L is equals to 0. So only R square is there, that is equals to R. So for only a resistive circuit, the value of the impedance of that circuit will be equals to R. If only resistance is connected in the circuit, so the impedance will be equals to the resistance. So in this way, we can define the reactance, inductive reactance, capacitive reactance, and we can understand that what is inductive reactance, what is capacitive reactance, what is resistance, what is inductor, what is capacitor, and we can find the value of the impedance from a series RL and RC circuit. Now, for this circuit, try to understand what is this. Here in this circuit, we have both resistance and inductance. This is the resistance, this is the inductance. So the voltage, so what is R? R is, the resistance is VR by I. The current which is flowing through this resistor, that is VI by R equals to VR by I equals to R, and VL by I equals to omega L. VL by I equals to omega L. So impedance equals to V by I, the total voltage divided by I. So in this way, we can find the impedance of a given circuit. So to prepare this video, I take help from this YouTube link and the book of Professor Abhijit Chakraborty. The name of the book is Circuit Theory, Networks, Analysis and Synthesis. So from this lecture, what we understand? We understand the impedance, the reactance, the resistance, reactance, impedance of resistor, inductor, capacitor, series. We find the impedance of a series RL circuit, series RC circuit, and series RLC circuit. And also, we measure inductance, what is reactance or impedance. We measure the value of the capacitor, that is 1 by omega c. It's called the capacitive reactance. We find the impedance for a series RL circuit, and we try to understand the equation of a scalar circuit and a vector circuit. We try to understand the significance of J. In the previous lecture, we talked about the J operator, that is equals to root over -1. And then we discuss about how to find the impedance Z from a circuit when it is a RL circuit. If R is not there, then what will be the value of Z? If L is not there, then what will be the value of Z? And then the value of the resistance, the value of the inductive reactance, and the value of the impedance of the circuit. So thank you all. Thanks for watching this video. I think this video, from this video, you at least learned something new, something different. So for any doubt, any confusion, you can contact with me through mail, or you can contact with me with WhatsApp message or in any other digital mode. Thank you all again. Goodbye.